Hey everyone, this is Fahad. I'll be talking about the topic renewable energy for smart cities. A very quick introduction about myself. I am a renewable energy engineer. I'm based in Australia, but I was born and raised in Bangladesh. I'm working as a renewable energy engineer here in Australia, and I'm also a consultant for a Swiss firm working on humanitarian projects for renewable energy. I also founded my organization called Eminate. We very recently at COP28 in Dubai, we organized three-side events there. It was quite successful. I'm very happy to announce that. And our main goal is helping disadvantaged communities with clean energy and climate action. And we're currently mainly focusing on youth. And as for myself, I have around 7 years professional experience, and I've been lucky to work with various development partners like World Bank, JICA, UTP, and so on. And I'm also part of three ambassadorship programs, which is the Max Atkins program with Dr. Nee, and then Al-Sharq, as well as I was also a global talent for Unleash. Finally, I did my master's in renewable energy from the University of New South Wales here in Australia, and my bachelor's was in electronics from Macquarie. All right, great. So, starting with smart city. What is basically a smart city? Right, it's a smart municipality where we use information and communication technologies to, first of all, increase operational efficiency. And we also have to share information with the public and improve the quality of government services and citizens. So having a look at this image, for example, it feels like a utopia, doesn't it? But as we can see, the quality of life, environment, government, everything, yeah, we make it smart in a way. There's more on that later. So as we can see, what are the components of the smart city? We have smart transportation, smart buildings, smart grid, smart health, everything is smart. So I guess my main focus would be smart grid or energy, and it's SDG goal 11, the UN Sustainable Development Goal, which is 11, sustainable cities and communities. So I've been talking about like all of these, like in a smart city, everything is smart. So what is basically smart, right? So the elements of a smart, sustainable city would be very, very high, and reliable internet connectivity. This would be 5G and beyond. This would be basically one of the foundations of a smart city. We will also need quality, continuous electricity, because without electricity, we all know the internet wouldn't run. We need very smart sensor technology, because from the sensors, we will get the data. And then from the data, we can make things smart. And obviously, very good IT infrastructure. And I guess everything culminates to data, and more data. And then once we get more data, we can enable machine learning. And then that's where AI comes in, right? So yeah, this would be the components. And I'm very happy to say that obviously renewable energy disruption is already ongoing in all parts of the world. Obviously, we know about climate change, and I'll say it's the best way to mitigate climate change because it's clean and green. The cost is obviously going down. We are also getting better storage for energy. Basically, we all know that solar and wind, for example, are intermittent. So they depend on how much sun we are getting or how much wind. But storage helps us with the intermittency in terms of grid stability. And obviously, I've talked about the cost going down, so it helps in economic feasibility, which means the payback period is getting smaller for these investments. And obviously, there is like a lot of innovation going on in our field. So from solar, wind storage to also like VPPs, which is virtual power plants, EMS, energy management systems, and so on. There are so many different innovations happening all the time. However, in order to incorporate more renewable energy into the mix, I've talked about how intermittent it is, right? To, let's say, target 80, 90, 100% renewable energy in the mix, we will need smart systems in smart cities, without which, to be honest, it's not possible to go, let's say, even 100% renewable energy, right? So like in an electricity management for smart cities, what do we need? I'll start from the bottom. So obviously in a smart electricity system, what are the requirements? It will, first of all, help save electricity and it benefits the environment. We've talked about the need for clean green energy and to mitigate climate change. We will optimize infrastructure investment. This is crucial because without this, this is what we need to, first of all, upgrade the grid and then make sure the intermittent electricity in terms of solar and wind that we're getting, the grid can actually handle this, right? And then maintain serviceability. With the grids getting more complex, we will have to make sure that O&M, operations and maintenance, is possible as well, prevents overload. Again, something we're seeing in Australia, for example, with so many distributed energy systems, which is residential solar, we see it's leading to grid instability in terms of frequency and voltage. So we will need to make sure the overload, the security function is robust in the grid. Like, for example, when there is high solar and from the residential solar, we are getting a lot of generation into the grid. We are seeing an increase in frequency, increase in voltage. So the grid needs to ensure that it has the capacity to stop this. Otherwise, it will lead to like massive blackout. And we will also need smart demand management, which is like demand side response from the customer side, right? So moving on. So like we've talked about the electricity management. So how do we get there? What do we do? So first of all, it's one of the main things that we need to do is get a digital twin. What is a digital twin? It's basically a simulation of the grid itself, right? So from the grid to the intermittent generators, to the storage, to everything else, we will make a digital twin for that. And then it helps with the, there are some really, really like good and complex software that we can use to simulate this. And then happy to announce that the simulation results that we get are actually quite accurate. And then Grid Edge is more on the customer side. So basically, Grid Edge is basically on the customer side. You know how we've talked about residential solar. This is basically a generation from the customer, right? So let's say making sure that they have an energy management system on their side to control grid export or demand side response from their side, DSR. So all of this will go into Grid Edge, so the edge of the grid. And then Internet of Electricity is basically Internet of Things for electricity, from which we gather data, and then we move on to other things such as smart grid, AI, and even like analyzing the data to understand how we can improve. Right. So the utility is basically, let's say this, right? Generation, transmission and distribution, customer management, right? This was yesterday. Why was this yesterday? Because this is a centralized system. The new system, the new electric grid or the new electric system that we're seeing is basically decentralized. So there will be solar systems in residential houses. Even we're seeing like small wind turbines in some places. Biogas has been attempted as well. So these are quite interesting. So currently what we're seeing is there is generation and then transmission and distribution, and then customer management is basically commercial consumers and residential consumers. It's like a linear process, right? But what's happening now is it's going by direction. So it's going both directions, as we can see here, right? So smart generation with advanced monitoring and controls, and then it's going transmission and distribution, and then it's going to the commercial and residential consumers, and then the corporate services, is being automated. So the main gist of this is basically the whole system is, first of all, getting decentralized, and it's getting bi-direction. So the system, the whole system, the grid, for example, has to be smart enough and strong enough, robust enough to handle all this, right? And moving on, the next thing I would like to focus on is transactive energy. What is transactive energy? This is basically a very intelligent multi-level communications method that coordinates energy generation, consumption, and delivery. So basically, a coordinated system for generation, consumption, and delivery. I've basically covered this indirectly, but this is this makes it a lot more structured. And this is what we would call the smart in smart electricity, smart grid, smart energy, and so on, right? So obviously the first requirement would be a very smart grid with upgraded infrastructure. I cannot emphasize on this enough. We need a very strong infrastructure, a very strong grid to be able to handle renewable energy in the electricity mix, right? Obviously, this will be two-way or bidirectional because the residential solar, for example, will be exporting to the grid as well, but also the consumers will turn into prosumers. So they will use and they will also export. So it's bidirectional. And then electricity can be directed as needed. We've talked about DSR, for example, demand side response, and then it's priced accordingly. It's obviously intelligent, the intelligence driving the transactive energy based on the market value. So there will be like very strong spot pricing for this, and then real-time dynamic pricing of energy based on demand, obviously. And then the decisions will be based on price signals, save end user money on energy bills. This is huge. This is very important because end of the day, we also have to make sure that the end user, they save energy, and then it will be transacted energy at retail. So just making sure it's at the retail level, right? Moving on. So the main idea for this was basically to show how complex this system might get, right? So we see the prosumer. So this is like, let's say a residential system. I'm not sure if you can see my cursor. So let's say this is a residential system, right? Where the customer is generating, so it's sending to the grid, but it's also consuming, right? And then there is residential consumer as well without solar, for example, and then commercial systems, and then obviously we'll have renewable energy sources, current sources, which is mainly fossil fuel. There will be storage, large-scale storage, and then utility grid as well. So the network operator will need to handle all of these. And as we can see, the red is the data. So there will be a lot of data interchange because the data will help us understand what is going on, what is required, and ensure we can provide this quality electricity, right? So to enable this, right, something we've talked about is data, right? How do we get the data? We need, obviously, very robust internet as well, right? So it is through the internet, like for example, I'm currently working in a startup where we have an energy management system, right? And then internet is vital for us to log into the system, to be able to control it, to be able to see, like, say, for example, the solar export limit. So just this is like an example from real life, but it's absolutely vital for us to have robust internet to be able to control or get or be able to start or have a smart grid. So as we can see from here, the utility distributors company, like everything over here, this relies on the internet. Then we will have virtual utility company for perhaps VPPs, virtual power plants, energy service providers. Everyone basically is relying on the internet. And then this is where the exchange of data takes place. I'll give you a cool example later as well. But another thing that, again, I think is not focused enough is when we talk about internet, there have been cases we will need to ensure that it's secure as well. There have been cases where smart grids were attempted to be hacked. So when a power grid is modernized, more network, leads to more digital technology when it comes to smart grids, right? So this gives an opportunity for hackers to steal the information or even shut down the system. And to shut down, for example, grid is like, it's a disaster, especially in the developed world, right? Because we're not really used to seeing blackouts, for example. So this will be a huge disaster and it will be a national risk. And cyber attack can lead to disruption of economy, obviously. It's a matter of national security and where billions of dollars are invested, obviously, in the electric grid and electric system. So utilities set tools to prevent cyber attacks, and collaboration and knowledge sharing to counter these threats are absolutely vital, especially it should be like unilateral, it should be amongst various countries to share the knowledge, right? And again, we'll also have to make sure new technologies versus continuous countermeasures, because the thing is, our renewable energy sector or even the energy sector, we're getting like new technologies basically every day. So we will have to also adapt accordingly, especially in terms of security to counter hacking. And then if a cyber attack is successful, the utilities need to be able to recover, because the threat, the national agencies should be capable of this, because again, this is on a like great massive national level, right? And again, I'll get to it. So because one electric grid, the electric grid we have in Australia, for example, it's like it covers the transmission covers 5,000 kilometers, and it has like it affects millions of people. So this is vital, and we need to and the utilities also need to identify and combat vulnerabilities. Like I was doing some research, and it seemed pretty cool. Like quite interesting actually. Like even like we have articles where they are saying how to hack a smart fridge. So the thing with like for example, smart fridges, smart TVs, um, they obviously have a lot of our own data, and if hackers can hack into them, they have a lot of our information. So imagine the effect, the impact, just hacking the national grid, right? So moving on, another thing I wanted to highlight is electric vehicles. So there is another disruption that's ongoing, which is obviously EVs, electric vehicles, because we are trying to phase out fossil fuel vehicles, which is basically ICE or internal combustion engines. So obviously EVs are definitely more sustainable. They can support the grid if necessary. So what I mean by that is that when it's connected to the grid, and let's say the grid is unstable, the the charge that's stored in the EV, it can be exported to the grid to make sure the grid stability is ensured. Obviously, the cost of EVs are also going down, and current EVs run on fossil fuel generated electricity. It's expected to change and also getting cheaper than ICE. But old inefficient fossil fuel driven vehicles will be on roads in developing countries after 2025, because again, this is massive infrastructural investments, right? So it would be unfair and a bit naive to expect that particularly in the global south, the ICE vehicles will really go down much. So more focus should be given on this as well. But another thing that we should keep in mind is when we have more EVs, let's say a community has like more, they bought EVs. The EVs will need to be charged, right? So this will change the consumption pattern. For example, let's say an EV runs the whole day, and then before the customer goes to sleep, like they charge their phone, they charge their EVs as well. So the consumption pattern will be such that at night, there will be high consumption for that one customer. And imagine this happens for 1,000 households, for example, just a little example, I suppose. So that will cause a massive increase in demand at night, right? And again, so there are more practices to try and change this, to make sure EVs are being charged during the day, for example, when there's solar. And again, we need more practices to make sure, we adapt accordingly. And another thing is the future supergrid. Hey, Dr. Ni, how am I doing on time?
For each speaker, you have to speak about the 20 minutes.
Okay, how much time do I have?
Yeah, it's okay. You can carry on.
Okay, all good. I'll be fast. Okay, so another interesting thing that's happening is the supergrid, which is definitely the future. So, like I mentioned, the strong grid is instrumental to support high penetration of renewable energy, right? So future grids will need deep integration of infrastructure and ICTs, right? And ICT will be crucial as new supergrids come online. What do I mean by supergrids? So the Asian supergrid, for example, this is between Russia, China, Mongolia, South Korea, and Japan. So basically, wind and solar from Mongolia's global Gobi region, hydro and thermal from Russia, PV and wind from South Korea and Japan, wind and solar from China. So all of these will combine, all of these generation sources will combine to make the Pan-Asian national grid, right? So this whole national grid comprising of various countries, hopefully, and the total distance or the total distance of the transmission would be 36,000 kilometers. This is huge. This is massive. So this is one of the goals that the world is going towards, and I think this is fantastic if successfully implemented. And obviously, the politics between countries, that should be sorted out as well. And yeah, so I wanted to give a quick example about the Australian grid as well. So this is our grid for the east, for the east side, as well as South Australia. So it's one of the largest interconnected electricity networks in the world, which is 5,000, which is not much compared to the super grid. But again, in terms of how things are in other countries, it's actually pretty good. And it enables trade of over 11 billion of electricity annually to almost 19 million end-use consumers. Right? We have a very good renewable energy penetration because Australia is lucky. We have a lot of solar and wind. So large number of DERs, distributed energy resources, such as residential solar. And we are also seeing a lot of solar wind farms and large-scale battery. But I wanted to quickly show an example. So this is what enables smart system. Do you guys see the Google Chrome? Right. So this is our Australian energy market operator, right? This is open to everyone. This is a data dashboard, right? So we can see generation and load and a lot of other things, ancillary services. So once we go to, let's say, ancillary services, here we can see like price data and lots of other data as well. And then let's say if I choose this, right? So as we can see, we can get literally 4-second data of ancillary services would be frequency, for example, or voltage and all that, right? So if we see this, Causer pays 4-second data. This is just an example. So in other pitches, we'll get even more. So this is literally 4-second data, which is open to the public, open to everyone. And we can analyze this data to, for AI, for example, and analysis to make sure to understand how we are doing. And another thing I wanted to focus on was the dashboard as well. So this is the dashboard, data dashboard for the national electricity market. So over here, we can see, for example, the renewable penetration. It's summer here in Australia. So very proud to say that the max we got is 72.1 renewable energy penetration, which is amazing, right? And as we can see currently, again, because it's summer, we're seeing really strong renewable energy penetration, over 70%. This is great news. And we can see that, again, we are getting to more and more renewable energy, which is mostly market driven, which is amazing. And also the fact that this is all open to the public and, we can see and work on this. So that's great to see as well. All right, cool. And moving on, I think should be almost done. Yeah, so that would be the conclusion. So the future, what does the future hold? Right, the future utility will develop and deploy like digital transactive energy techniques, as mentioned, techniques for managing the generation, consumption, or flow of electric power, the use based on economics and market values, obviously, potential solution for future vast power demand, because definitely the power consumption of customers is increasing, but also people who, let's say, have not had access to electricity, for example, that's increasing as well, which is also great news. Again, super grid for intercontinental connectivity, and that leads to no monopoly because, again, it will be more distributed, won't be centralized, it will be rather decentralized. And transactive energy can determine the future of 21st century's intelligent and secure power systems. But another question that we should keep in mind is definitely like the hacking thing. So what to do with the hacked smart refrigerator? Like, let's say if my refrigerator, which is smart, is hacked, what do we do? And then keeping that in mind, imagining and thinking, if that happens to the grid, what would be the implications, right? So yeah, that would be it. Thank you for attending the presentation. It would be wonderful if you guys can like my page on Instagram. And yeah, hopefully you found it beneficial. Thanks a lot.
Thank you so much, Mr. Faidas, for your great lecture talk and the presentation. I really appreciate your lecture, especially for the smart city from the perspective of the renewable energy. Yeah. Is there any question from our student side? I would like to invite the question. Do you have any question?
No, sir.
Okay. How about the other students? Okay, so if I have to ask the question for this session, that I want to know from my side the first question is about so according to your lecture of to become a smart city, the internet is very important. So I would like to know how much is important to become a smart city, or how we can use the internet effectively for creation the smart city. Yeah.
This greatly depends on the on a lot of factors, on the size of the electric utility, on the size of the grid, the size of the population as well, even because that depends. It shows the number of customers from which we need the data, right? So I'll give a quick example. Like again, here in Australia, the population is roughly 25 million. And again, like I mentioned, the east side and the south side is more 19 million. And um, the the internet connectivity is actually pretty decent. It's pretty strong. But again, like from experience, whenever we see like an outage, for example, we had a huge outage like a few weeks ago. So that completely disrupted like our system, how we were working, but also like the utility in terms of how they were getting the data. So yeah, the I guess to answer your question, it again depends how much infrastructure investment is needed. But yeah, just hopefully they're saying like 5G should be more than enough because again, when we talk about smart city, electricity is just one aspect. Then there's smart health, smart transport, smart everything's smart, right? So I was even hearing like they're doing some research on 6G. So I guess yeah, implementing 5G would be a great start. And then from then on, perhaps we can move on to, yeah, better internet and more reliable internet.
Thank you so much for your answer. Okay, so I want to invite the other question from the students. Do you have any question?
Yeah.
Okay, you can.
Okay. You're talking smart city as a internet view and electric energy view. So what else out there in other views, like other perspective for smart city?
Sorry, it was a bit hard to hear you, but was the question more apart from um, internet and smart infrastructure, what else can be needed?
Yeah.
Yeah. To be honest, these two would be the greatest requirements. So once this would be the foundation. So the foundation would be a smart internet infrastructure, smart grid infrastructure, and then let's say private companies, private companies, or even like customers, they can install their own solar farms can be installed, wind farms can be installed, and then that will connect to the grid, basically, right? So once this strong foundation is set up, automatically more renewable energy can be implemented into the energy mix. So once that is done, obviously there will be other issues in terms of, let's say, policies. Policy is a big one, making sure we get good policies from the government, and then once and transmission and distribution as well. So yeah, so there would be like a lot of other aspects, but I think as a start, focusing on these three is important because this may be just 2 points, but it requires millions and millions, like billions of dollars, literally, not millions, right? It will require a huge investment, a lot of engineering, because it covers the whole country, right? It will cover the whole country in terms of internet and electricity. So, yeah, that's why it would be a good start to focus on these two things. It's a good question, by the way.